Hi, I'm Marc Salit, and I'm happy to have coordinated at the best, is probably the best description, conversation around standards. And is this going to work? Maybe. Did it come up? Okay. Did it again. Um, and I'm from the National Institute of Standards and Technology, or NIST, and I have at least 8 mutually incompatible passwords to log into IT systems for authentication of identity. I have a smart card ID, and I have an RSA token. And so you should know that. And because of that, I keep all my passwords in an unencrypted text file on a cloud drive. Um, so, um, yeah, there's a standard. Um, and 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 the only interesting standards, I've been doing standards for 30 years. The only interesting standards are the ones that get used, and really the only interesting standards that get used are the ones that make things less painful than not having them. And so what that's about is that standards come up when you want to share stuff. Distribution of labor, and ways to coordinate things that you can't do on your own. I mostly work in metrology and work on quantitative measurement results, and the deal is you need to compare results. If I'm measuring the lead in drinking water, I need to be able to compare that meaningfully to a reference of what's good or what's bad, or is this less than it was if I'm trying to remediate something. I'd like to say that a measurement that can't be compared is the sound of one hand clapping. Um, and, and, and so there's a little philosophy in this. So the engineering biology community brings the spirit of engineering, or the synthetic biology community brings the spirit of engineering and the real interest in being able to build on each other's work and share results in a meaningful way, which means you need to be able to compare. I like to use, and some of you have probably been subject to my little story here, I like to use the idea of a terrarium. So many synthetic biology projects are so awesome, and they've been crafted like a terrarium. And there's an amazing ecosystem inside that glass box. And this is what synthetic biology sort of looks like, absent being able to share ideas, absent being able to share results of work, absent being able to share genetic parts or systems, absent being able to have ways to do these transactions that are accurate and efficient. So what's it going to take to get there, to an ecosystem? And so what's an ecosystem look like? There are transactions amongst functional elements, and standards support those transactions with abstraction and a whole list of stuff you've got there. Reliability, and again, enabling the distribution of labor across multiple entities. That's what a project like this looks like to a guy like me. The ability to do things together. There's a room full of awesome investigators that we're talking to each other, and it's super exciting. The value add, I think, of this being a project are spin-outs like standards that will enable transactions that will endure beyond the novelty or the amazing accomplishment. I won't diminish it with faint praise. The amazing accomplishment of being able to synthesize and operate large genomes, and therefore engineer large genomes. But the standards that are going to let us do that as a community, instead of the bespoke work in individual labs, offer a value that would potentially change the world in as big a way as just the ability to do that. So what's going on inside a terrarium? I think I've got a, there we go, is you've got some kind of workflow, and this is some silly canonical workflow where you've got a concept for a project, and it reduces to biological processes that reduce to sequences at some point, that reduce to actual manufactured nucleic acids that then get composed into parts or genomes that then let you engineer organisms and go into some kind of operation or production. And the deal is that you've got lots of these, and there are lots of enterprises happening, and the transactions can be explicit, and so we've color-coded the different organizations that are operating together. So you've got an organizational boundary where an organization has to do a handoff that can be done, again, accurately and efficiently. Or really, inside every organization, there's some workflow, and don't please, overthink what's inside the little boxes, but rather the idea is that you've got some kind of workflow where there's distribution of labor across, and it could be across a team of graduate students, it could be across a group of laboratories that are part of GP Wright. So what does that reduce to? And there's these transactions. How do you make that happen? What's the value proposition for standards? And we didn't, by the way, identify a lot of things that ought to be made, like a lin pack for sequences, like can you have some canonical set of sequences that will prove the accuracy and validity of a particular synthesis project. We didn't get into that level yet, because frankly, the synthesis of standards is going to depend a bit on the shape the project takes. But the principles, the whole's greater than the sum of the parts, enduring standards are a valuable potential spin out from the project, and will create an ecosystem ready world. And you're getting a little opinion here, and I don't think that the folks at the table would disagree. This isn't going to happen as well or as soon unless there's a project like this with a coordination or coherence framework on top of the amazing research that's going on in the individual investigators and labs and the investigator-driven funding from the various stakeholder agencies and other fund sources. This has to be professionalized. Standards that are going to be effective have to be somebody's day job. This can't be just spin out of, oh, well, we've got to figure out how to hand this off, because you won't have anything that functions reliably and accurately and efficiently at the genome scale unless it's thought through a bit and, again, engineered. There are existing standards to build upon that need extension, and of course, not to be soft-pedaled. It's a critical element in commercial adoption of the fruits of this project across society's various spots. So that's the pitch on standards. I'm sort of in a wait and see to see who shows up ready to do the work and how we can resource it. Happy to entertain questions or remarks from anybody who was at the table.
I wasn't at the table, but I'm really hearing what you're saying, and as you point out, doing this right costs money. And I don't know how much you can tell us about this, but how seriously do you think NIST is interested in resourcing and supporting this type of work? So, for example, we did the yeast genome on a shoestring with minimal data standards. We basically used the nucleotide as the data standard, which gets complicated. So I know I'm exaggerating, but for example, would there be interest in taking the design that's finished now and kind of reformatting it into a more professionalized, standardized format? Would this be the kind of project that NIST might be interested in? I know it's not a question for the working group, but I'm
Sure,
asking.
no, and NIST, of course, is not a funding agency typically for extramural projects, but we have some resources internally. We should talk, and it might be grist for the mill as we do standards development towards a genome scale representation. There's a question in the back, Nancy. Did you? Yes. Of representation of SE 2.0 in a computer. It's not at the design level that would. The answer is, if that was the direction to spin it up, and I'm going to ask Jake to remark on that also, but if that was the direction that would be a totally viable path to extending SBOL and evaluating SBOL at the genome scale. Jake, did you have any?
I was going to basically say almost exactly that so one of the things that was done recently as a test with SBOL was taking the entire iGEM parts database and importing that and making that publicly available as an SBOLized resource as well. And so if SC 2.0 was interested in working with folks in the SBOL community on that as a test project, I think that there would be a great deal of receptiveness there. Speaking on behalf of the steering committee.
All right, thank you, everybody, and I'm easy to find. Salit at NIST.gov, and I have a thick skin. Thanks.